Collected like terms. So I've got 5p, I've got negative 3p, and I've got positive p. So that's the same as 5 minus 3, which is 2, plus 1, which is 3. So this is actually 3p. M cubed plus m cubed, you'd put them together. It's not as complicated as you think, it's just 2m cubed. Some people might think it's m to the power of 6, but that would only be really if it was m cubed times m cubed, which it's not, so it's a load of rubbish. And this one here, what I like to do is I like to circle the d's. So I've got 5d, I've got negative d, I've got positive d. So 5 minus 7, so 5, 6, 7 is minus 2, plus 1 is minus 1d. These two actually stay the same because I can't connect them. So it's 10 plus 3c. Okay, and minus 1d. Question 2. Right, that's actually 56.78 to one significant figure. My significant figure is my 5. So I look at my 6, does that push it up or down, or push it up? So my answer is actually 60. Okay, what's the most popular type of transport used by the boys? So boys are one that's shaded, so it's going to be walking, because walking's the highest. 7 girls walk to school. Show this information on a bar chart. So here's 7, go across. Bar. Try and make your bar the same length, so you can get a ruler to check this. The girls need that zigzag, so let's try that zigzag all the way in, otherwise it's wrong. Doesn't really matter, I've done it in purple, it's just a pen that I was using at the time. And that's it. Yeah, right. More students get to school by car than by bus. How many more? First of all, let's work out how many people get there by car. Car is 5 boys and 9 girls. So I have to do 5 plus 9, which is 14. Bus is 6 boys and 4 girls. So 6 plus 4 equals 10. So the answer is 4 more. Last bit, the number of students in year 5 is the same as the number of students in year 6. What is the total number of students in year 5 and year 6? So we're going to have to work out all of them first. So let's add them all up. Boys for car is 5, and girls for car is 9, bus is 6, and for girls it's 4. Walkie is 9, and for girls it's 7. For cycle it's 4 for boys, and for girls it's 1, and for other it's 2, and for girls it's 1. Okay, just gotta add them all up. 5 plus 9 plus 6 plus 4 plus 9 plus 7 plus 4 plus 1 plus 2 plus 1. Okay, it's 48. It's asking for both years, so I have to double it. Okay, G equals 96. Alright, question 4, order from smallest to largest. There's 2 ways we can do it. We can either give them all the same denominator, or we can turn them into fractions. Let's give them all the same denominator first. Now we need the lowest common multiple of 5, 30, 2 and 15. It happens to be 30. So I'm going to put all of these over 30. 11 over 30 just stays as 11 over 30. To get to 15 to 30 we times it by 2, so we've got times 7 by 2, which is 14. To get 2 to 30 we need to times by 15, so we've got times top by 15, which is 1 times 15 is 15. 5 to 30 we times it by 6, so we've got times the top by 6. Now it's just a case of putting your numerators in order. So 11 is your lowest, and it's 14, and it's not 14, sorry, it's 12, and then it's 14, and then it's 15. And the other way you can do this is we can change them all into decimals. So if I do 2/5, it's just 2 divided by 5. Okay, let's do 0.4. 0.4. 11 to 30. We can just type in 11 over 30. Your calculator, press S to D, which is 0.36 reoccurring. And 6 is reoccurring. Half is 0.5. If you didn't know that, it should really. 7 over 15, 7 divided by 15 is 0.46, and 6 is reoccurring. Now I'm just going to give them the same amount of decimal places just to make it easier to do this. Right, and then again your lowest is 3/6, so it's lowest, and then it's 0.4, and then 0.46, and then 0.5. David sells CDs in the shop. Tally chart shows information about number of CDs David sold. Right, one down, one thing that is wrong with this tally chart. There's only ever two things that can be wrong. Either these things here are not 5, so I might have done like 5 then a thing, or this total's not right. But let's just check. 5, 5, 5, 5, 5, these are all 5s. Let's check for totals. 5, 6, 7, 8, good. 5, 10, 15, 16, 17, 18, that's correct. 5, 10, 11, 12, 13. So even though it says 12, it should really say 13. So I'm going to say the frequency shows 12 when the tally shows 13. Now I haven't said that the frequency is wrong because it could be the tally is wrong. David drew his pictogram showing information for Tuesday and Wednesday. Write down one thing that's wrong with this pictogram. Right, so if all of it represents 3, you've got 3, 6, 9, 12, 15. So this is 15. Let's work these ones out. 3, 6, oh wait, this ain't 9, this is really 1.5. So this really means that it's got 7.5 CDs. So I'm going to say you can't have 7.5 CDs. Okay, there's 495 coins in a bottle. A third are pounds, 124 50p's, the rest are 20s. What's the total values? Right, just to find out how much are pounds. So it's a third, I'm just going to type in a third. Press right, of 495. That means that's 165 pounds, which obviously equates to 165 pounds. 124 50p's, so I'm going to put 1.24, sorry, 124 times 0.5 is 62, so that means it's equal to 62 pounds. Now the rest are 20p's. Let's work out how many rest. We know there's 165 £1 coins. I'm going to add the 124 50p's. Okay, I'm going to take this away from 495, so 495 minus my answer is 206. I know that they're 20p each, so I'm going to times it by 0.2, which is £41.20p. Okay, and actually write this down because you get marks. The total values have added them all up, so that's plus 62 plus 165. Okay, let's do S to D. My answer is £268.20p. It's important to put your 0 for the 20 as well. Right, probably the fridge is faulty, is 0.015. Probably the fridge, well, so what is the probability the fridge does not have a fault? Okay, well there's no other options, so faulty or it's not faulty, so I know this plus, so 0.015 plus something must equal 1, because they're all possible values. So to work this out, I need to do 1 minus 0.015. It's calculator paper, so I'm going to use my calculator. 1 minus 0.015. And my answer is 0.985. That's it, no more complicated. Here is a list of numbers. I'm not reading them out. From the numbers in the list, write down a square number. Right, a square number is a number times by itself. So let's write out the square numbers. 1 times 1 is 1. 2 times 2 is 4, that's not there. 3 times 3 is 9, that's not there. 4 times 4 is 16, it's not there. 5 times 5 is 25. Oh, it's this one here. So I'm going to write 25, I'm going to put a ring around it so it's clear. From the numbers in the list, write down a number that is a multiple of both 4 and 6. So let's write multiples of 4. So 4, 8, 12, 16, 20, 24. Oh, 24 is there. But let's see if it's a multiple of 6, just in case. 6, 12, that's not there. 18, sorry, 24. 24 is there. So I'm going to write 24 here. Big ring around it. Write down all the prime numbers in the list. So let's just go through them, let's eradicate. 21 goes into 3 times 7. Oh, sorry, a prime number's only got 2 factors, itself and 1. 22 is even. In fact, I'm just going to cross off all the even numbers because 2 goes into them. 5 can't be because 5 goes into them. So I've got these 3. And so let's look at 27. 3 actually goes into 27. So it's 23 and 29. So it's 23 and 29. Now, if you're a bit bad with your prime numbers and you don't know, you've got a prime factorization button here. And this can check to see if a number's prime, because if a prime has only got one prime factor. So I press 29, I press my equals button, and it's important to press your equals. Shift, FACT, goes back to 29. So we know that these are both prime numbers. Right. Find the value of x. Easiest way is to create an equation. Now I know all of these will have to add up to 360. So I know 360 is going to be this angle here, which is 90, plus 2x, plus 3x. I'm going to put my x's together to make 5x, keep everything the same. Now I've just got to solve this. It's written in a bit of a weird way, but we get our numbers away first. So minus 90 minus 90. This is a calculator paper, so I'm going to use my calculator paper for 360 minus 90. 270. These cancel out, which is 5x. And to solve it, I divide by 5 divided by 5. So I'm going to do 270 divided by 5. 270 divided by 5 is 54. These cancel out. So 54 equals x. 54 is x. Just be careful, because this says find the value of x, but some of them might say find the smallest angle. Just read the question to make sure. Okay, Shusha is going to buy 150 envelopes. Here is some information about the cost of the envelopes in two shops. Shusha wants to buy the envelopes as cheaply as possible. Which shop should Shusha buy 150 envelopes from? You must show how you get your answer. Right, I'm going to divide my page up. I'm going to write letters to send. Right, 150 envelopes, so we want to know how many packs we want. I'm going to use my calculator as much as possible. So it's 150 we need. Packs are 25, so I'm going to divide them. So I need 6 packs. 6 packs. Okay, I know that they're £3.49 each. So I'm just going to multiply them. That's 3 times 3.49 STD. So my answer is going to be £20.94p. Now we'll look at stationary word. Right, pack of 10 envelopes for £2.10. Buy 2 packs and you get 1 pack free. So essentially that means for every 3 packs we buy, we're only really paying for 2. But obviously if we pay for 2 packs, we're still paying for 2 packs. So I really want to see how many 3 packs do I get out of the 150. So first of all, a pack of 10 envelopes, there's 150, so I'd do 150 divided by 10, okay, which is 15. But again, you've got to think for every 3 packs, I only really pay for 2. So I'm only really paying for 10 packs, but then I get 5 free. Because that's the way the ratio works. It's £2.10, so all I'm really doing is times in the 10 packs by £2.10, so I get the 5 free. 10 times 2.1, which is £21. So which one is cheapest as possible? You've got to make it clear. I say letters to send is cheapest. Now I always like to write something to tell me it's cheapest, so I'm going to write the difference. So I'm going to subtract the differences. Let's do it properly. Which is, so it's by 6p. And that way there, this statement here is really all you're working out, because the examiner could actually know that you've done all this working out just by writing down the 6 pence. Okay, question 11. You can use this graph to change between inches and centimetres. Centimetres, inches. Change 74 centimetres to inches. So I'll find 74, which is here. Go along to the line. Actually it's 70, so yeah, that's full. Go along to the line. You're going to use a ruler and go down. Okay, so that's 25, 6, 7, 8, 9. So that's 29 inches. Alright, second part of the question. Daniel's height is 6 feet 3 inches. 1 foot equals 12 inches. What is Daniel's height in centimetres? Now let's look at our scale. Our inches go up quite high, so let's change this into inches. So I've got 6 foot will equal 6 times 12. Okay. I'm use my calculator to do this. Turn on. 72. Plus my 3 inches, which means it's 75 inches. Now my graph doesn't actually go up to 75, so what I'm going to do is I'm going to read it from 50, and I'm going to read it from 25, because 50 plus 25 is 75. So 50, I go up, I'm going all the way along the outside, up to here, then I'm going across. So if that's 120, that's 130, so it's 138. And I need to do my 25, which is here, go up. And it is important to put these lines on your graph, because this is your working out. Just remember this is a different scale, so this is actually 62, because every square one is 2. Then I just add them up, 38 plus 62. It's calculator paper, so I'm going to use my calculator. Equals 200. So the answer is 200 centimetres, which is 2 metres, but it's in centimetres. Find square root of 13.4 minus 1.5 all over 6.8 plus 0.06 squared. Right, I'm going to type all of this into my calculator. I'm going to use my fraction button. Now, square root of 13.4 minus 1.5, that looks exactly the same. Let's go down to the denominator, brackets, 6.8 plus 0.06 brackets squared. Okay, I've got decent press, so I just press equals. It normally says write down all the numbers on your calculator display. So 0.07330359081. Sometimes this will give you it in like a form, a weird form, so like as a fraction, to press S to D. Now if you haven't got a decent calculator, what you've got to do is you've got to do the numerator and then you've got to do the denominator. So let's say I haven't got like a decent calculator. So let's say I've got this budget thing. First of all, let's type in my numerator, which is the square root of 13.4 minus 1.5. So if you got this answer here, 2.16, this is not right, because your square root is just on the 13.4, it's not really on the 1.5. So to change it, you have to put everything in brackets at the top. Okay, now this will square root all of it. Okay, now I'm going to write this down. I'm going to write down most of the numbers. Okay, so 3.449637662. Now I'm going to do the denominator. Denominator is already in brackets, so I just got to type that in. So now it's bracket 6.8 plus 0.06, all of it squared. So that's definitely my denominator. Press equals. 47.0596, and I will get marks for this if I do it. Now I'm just going to use this as divide sign because I've got a rubbish calculator, or I don't know how to use my calculator. I know it seems like a long number, but I'm going to type all of the top in. I don't actually need it to be that accurate, but I'm doing it anyway. Press and divide number, and I'm typing all of the bottom bit. 47.0596. Press equals. And I've got exactly the same number I got here before, 0.07330. Okay, here's the grid. The question is rotate shape A 90 degrees clockwise by centre A. Now clockwise is the way of a clock, so it's going to go around there. My centre 0 here. And normally what we'd do is get a bit of tracing paper, we'd trace it and we'll move it. But I don't have tracing paper. So I know that's 2 across 1 up. So I know when I rotate it, it's going to be 1 across 2 down. Okay, this is 1 across 4 up. So I know when I rotate it, it's going to be 4 across 1 down. This one here, I'm just going to cheat a little bit. I know it's just going to be above it, but it's 3 down, 1 across, so 3 across, 1 down. This one here is 4 down, 4 across, so it's going to be 4 across and 4 down. Okay, and you just join them all up. Ask yourself, does this look like this shape? Move it around. This does. I'm just going to label it A dash because that's sometimes what we do, but you don't have to. Second part, describe fully the single transformation of B onto C. So it's B onto C. Now it's not a translation because they're the same, it's not rotated, so it's got to be a reflection. So you've got to put reflection. And we have to give a line of reflection. So it's on line. Now you can either put y-axis, or if you actually wanted to put a line, this line is actually x equals 0. Okay. Either version's fine, but make sure you put the word reflection and you put the line of reflection. Right. Factorise 5 minus 10m. Biggest number I can take out of both is 5, because 5 goes into 5, 5 goes into 10. And no letters I can factorise out. 5 times 5 is a 1, there's a minus. 5 times 2m is 10m, that one's done. Factorise fully, 2a squared b plus 6ab. Now I find it's easy to write this out as 2aab, because that's a squared b, plus 6abb, and this bb makes b squared. So that's my biggest number I can take out is 2, and it's not because 2 is my biggest number, it's just 2 goes into 2, 2 goes into 6. We have an a in both, and we have a b in both. Now because I've got an a in both, I can cross this a out and cross this a out. Because I've got b in both, I can cross this b out and cross this b out. 2 divided by 2 is 1, so I can cross that out. And then 2 divided by 6 is 3, so I'm changing that to a 3. And it makes it a bit easier, because I know 2ab times a actually will give me 2a squared b, plus, and it's just 3b, because I've got 3 and a b, and I know 2 times 3 is 6, a is your a, and b times b is b squared, and there's your answer. Write 4.7 times 10 to the power minus 1 as an ordinary number. So this minus 1 means my decimal place is going the wrong way, so let me just write 4.7. This minus 1 changes it to here, which will make it 0.47, so the answer is 0.47. Now remember, this is a calculator paper, and it won't always work, but let's just type this into my calculator. So 4.7 times 10 to the power of negative 1. Oh, I got 0.47, so I could have done it with the calculator, no brain. Work out the value of 2.4 times 10 to the power 3 times 9.5 times 10 to the power 5. Now, I'm going to do it two ways. First of all, I'm just going to write it into my calculator, see what happens. So brackets 2.4 times 10 to the power 3. Make sure that's right, 3. Times brackets 9.5, 5 times 10 to the power of 5, in brackets. So I've typed in exactly what it says. I've got 2 to 8, that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now all I need to do is convert this into standard form, because it is. So it's going to be 2.28, because my number has to be between 1 and 10, times 10. I just need to work out now to put there. 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the power 9. There is another way you can do it. Now, what I'm going to do is I'm going to times my numbers first. So I'm going to do 2.4 times 9.5, okay, which is 22.8. And then I've got times my indices. So I'm putting times 10. Now, when you times your indices, we keep your base number and we add it. The other way you can think about it is this one here is 10 times 10 times 10, and that is 1, 2, 3, 4, 5. But together we've got 1, 2, 3, 4, 5, 6, 7, 8. 5 plus 3 is 8. Okay. Now this actually ruins the rules of standard form, because 22.8 is too big of a number. So if I make this one 10 times smaller, to adjust I need to make this bit 10 times bigger. Both answers are the same, and it doesn't matter which way you do. A, B and C is 3 points on a map, A, B and C. Right. 1 centimetre represents 100 metres. T is 250 from point A. The point T is equidistant from B and point C. On the map, show one of the possible positions of T. Right, first of all, I'm going to draw all the points that are 250 metres from point A. Now, as we said before, 1 centimetre represents 100 metres. So 250 metres will be 2.5 centimetres. So if I get my ruler properly, I'm going to get my compass. I'm going to measure 2.5 centimetres. 2.5. Okay. I'm going to put on point A. I'm going to draw a circle around it. This represents all the points that are 250 metres from point A. Now T is equidistant from B and C. So what this means is that every point is in the middle. Now what I'm going to do here is I'm going to measure the distance from B to C, okay, which is 7. And 3.5, so I'm just going to draw this line actually. 3.5 is my equidistance. Now I could use my compass and I could bisect it, but instead I'm just going to draw a line. And this line has to be at right angles. And I'm making this dash just to make a thing. Now every single bit of this dashed line is at equal distance from C and B. And if you don't believe me, I'm going to choose this point here. That's 4.5. And if I do it from B, it's also going to be, if I measure it properly, 4.5. So the question is, I have to mark a point which is 250 metres from A and is equal distance from point BC. So I can either mark this point here, or I can mark this point there. Either one would be fine. So this could be T, or that could be T. Right, the table shows probabilities of biased dice will land on a 2, 3, 4, 5 and 6. Neymar rolls the biased dice 200 times. Work out estimate for the total number of times dice will land on 1 or a 3. So first thing I'm going to do is I'm going to work out how much of 1 is. Now all of these will add up to 1. So I know 0.17 plus 0.18 plus 0.09 plus 0.15 plus 0.1. If I do 1, take away my answer, I know that's going to be 0.31. So I'm just going to write that in. 0.31. Now, the total number of times will land on 1 and 3. So 0.31. And a 3 is 0.18. Now, there's loads of ways we can do this. But what I'm going to do is I'm going to add these both together. So it's 0.31 plus 0.18. Which becomes a fraction, which is 0.49. Now, because it's 200 times, I'm going to times that by 200. Okay, so I times that by 200. And I reckon it's going to happen 98 times. Okay. And it sort of makes sense, because if I add both of these up, I've got roughly about half. Yeah, this is roughly about half and a little bit less. On Saturday, some adults and some children went out to the theatre. The ratio of the number of adults to the number of children was 5 to 2. Each person had a seat in a circle, had a seat in the stalls. 3/4 of the children had seats in the stalls. 117 children had seats in the circle. There was actually 2,600 seats in the theatre. On Saturday, were there more than 60% of the seats filled? You must show you get your answer. So essentially I'm going to work out how many people were actually there, and I'm going to put it over 2,600 and see if that works out to be 60%. Now I'm going to draw a little table just so I can work it out. It's like a 2A table, so it's adult, child, let's put total, sometimes that helps us, and then it's seats, stalls, and seats in the circle, and let's put total, because again sometimes that helps us. Let's put this down. So 170 children had seats in the circle, so children in the circle, that's 117. Okay, I'm going to put a ring around that because I've already used that data. Right, next one, 3/4 of the children had seats in the stalls. So if this is 3/4, that means that is 1/4. So if I've got 1/4 and I'm going to get 3/4, I just times it by 3. So I'll do 100 and, that's this, on 117 times 3 equals 351. Now I'm going to work out the total just by adding these together. So add 117. 7 equals 468. Okay, now I've got this 468. We use a ratio to work out the amount of adults, if you want. So let's just think if it's 5 to 2. What I'm going to do is I'm going to divide this by 2 to get what 1 is, and I'm going to times it by 5 to get what 5 represents. So it's 468 divided by 2. That's what 1 represents in my ratio. We'll times that by 5, which is 1,170. Add them both up to get my total, plus 468, which is 1,638. Now I haven't filled out the rest of this table. I could have if I wanted to, and there might have been shortcuts, but these are the amount of people that came to the theatre. So I'm going to put 1638 over 2,600, and see what percentage that gives me. So 1638 over 2600, S to D, which is 0.63, which is 63%. So my answer is going to be, there was more than 60% filled there was 63%. Diagram shows a prism with a cross section in the shape of a trapezium. Front is that way, side is that way. On the centimetre grid below, draw the front elevation and the side elevation of the prism using a scale of 2 centimetres to 1 metre. Okay. Now before I'm doing, I'm just going to rewrite all the measurements just so I don't get confused. So 2 centimetres is 1 metre. So it's going to be 4 centimetres. That's also going to be 4 centimetres. 1 metre is going to be 2 centimetres. That's going to be 1 centimetre. It's going to be 5 centimetres. That's what that is 1 centimetres. And essentially I'm just doubling it and putting the word centimetre on it. So it wants the front elevation and the side elevation of the prism. So it doesn't need the plan. So I just want the front and the side. Let's do the side first, just because it's easier. Okay. So it's going to be 1 centimetre up, 2 along. So, and this is centimetre grid, so it's 1 along, 2 across, and that's it. Now my front, it's going to be slightly different, but I'm going to start this side. It's 4 centimetres down, so it's 1, 2, 3, 4. Okay, across is 4, 1, 2, 3, 4. I'm going up, that's 1 centimetre. And this is going to be my diagonal. It looks a diagonal here, so it's going to be a diagonal there. So I'm just going to join them up. Okay. And that's it. It's not asking for a plan, but just for the hell of it, I'm going to put a plan view in. It's not asking for it, which is just going to be the top. And I'm going to cheat. I'm just going to look at my base, which is going to be 4 centimetres going across. 1, 2, 3, 4. 2 centimetres going down. 4 centimetres going across. 2 centimetres going down. And that's it. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. His average speed from Liverpool to Manchester was 70 kilometres per hour. He took 75 minutes to drive from Manchester to Sheffield. Work out Ollie's average speed for the total drive from Liverpool to Sheffield. Now I think this is the most confusing because there's a lot of words. So I'm actually going to write out Liverpool to Manchester. And he drove from Manchester to Sheffield. I'm going to put the information I have. So I know this is 56 kilometres. And then from Manchester to Sheffield is 61 kilometres. Okay. His average speed from Liverpool to Manchester was 70 kilometres per hour. This means I can actually work out the time. Then he took 75 minutes to go from Manchester to Sheffield. 5 minutes. Okay. Work out Ollie's average speed for the total distance of it. Now, when you don't get confused by thinking that average speed is the speed of this plus the speed of that divided by 2. Because the distances are different, it doesn't work. So what we have to do is you have to work out the total distance from Liverpool to Manchester, Manchester to Sheffield, and the total time, and we do our speed equals distance over time. So speed equals distance over time. Some people like it as a triangle. I'm not a big fan of a triangle. I'll always stick to this formula and just rearrange it. So I've got my distance, got my time here. I've got my distance, got my time, my speed here. So I need my speed for this first bit. So speed is 70 equals my distance is 56 over time. To work this out, I've got times both sides by time equals 70t equals 56, and I've got to divide it by 70. It's divided by 70. So my time is 56 over 70. I'm going to type into my calculator. 56 divided by 70, 0.8. And remember, this is in hours. Okay. Now, let's have a look at this. This is in minutes. So I'm going to convert my 75 minutes into hours. So I know 60 minutes is 1 hour. Now, so I've got 15 minutes left. Now this 15 is 15 over 60 hours. Okay. So I'm going to type that in. 15 divided by 60, which is quarter. So that's 1.25 hours. And it's important to keep all of this in hours. Now, to get my total distance, I'll do my 56 plus my 70. 56 plus 70, 126 kilometres. And my time, I'm going to do 0.8 plus 1.25. So 0.8 plus 1.25 equals 2.05. Speed equals distance over time. My distance is there, my time is there, so I just have to divide them both. 126 divided by 2.05. So it's actually 61.46 kilometers per hour, and I'm rounding it to 2 decimal places just because that's fairly accurate. And there is a part B to this question. Janine drove from Barnsley to York. Janine's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janine says the average speed from Barnsley to York can be found by working out the mean of 80 to 60. If Janine is correct, what does this tell you about the 2 parts of Janine's journey? Right. It actually means it took the same amount of time for both. So I'm going to have to put both parts of the journey took the same amount of time. ABC and EDC are straight lines. Okay, EA is parallel to DB. E to C is 8.1. So write that down. 8.1 is all of this. D to C is 5.4. D to B is 2.6. Work out the length A to C. Now you might think this might be a trigonometry question, or it might be Pythagoras questions. It's not. You can use trig. You're just going to do a lot of ones of this, but it's actually similar to triangles, because this triangle here is an enlargement of this triangle here. Okay. So all we need to do is scale factor. So if I get a smaller triangle, I want to do 5.4 times something equals 8.1. Okay. So I'm just going to have to divide both sides by 5.4 to solve it. So I know my scale factor is 8.1 over 5.4. I'm typing my calculator to see if I actually get something decent. 8.1 divided by 5.4. So my scale factor is 1.5. And what that means is, that smaller, whatever length's on the smaller one, I times it by 1.5 to get the length of the bigger one. So this length here corresponds to that length there. So I'll do 2.6 times 1.5, and that'll give me the length of A to C. So 2.6 times 1.5 equals S to D. So the answer is 3.9 centimetres. Right, now, here's part B of the question. AC equals 6.15. So I'm just going to use this. This is a new copy I'm using just to explain it. 6.15. It wants me to find the length of AB. So it wants me to work out this length here. Now we use the scale factor of 1.5 to work what BC is, but instead of timesing it, we divide it. So now 6.15 divided by 1.5 will give me the length of BC. So I'm going to type it in. 1.5 divided by 1. So it's, which is 4.1. So now this length to this length is 4.1. Now to work it out now, just do 6.15 take away 4.1. So 6.15 take away 4.15, whatever it is. So the answer, so A to C is 2.05. Anil wants to earn £25,000 for 3 years in a bank. We've got personal bank, which is 2% for each year, or secure bank, which is 4.3% for the first year and 0.9% for each extra year. Which bank will Anil find the most money in? Right. Let's do the personal bank. It's compound interest. So it's going to be 2,523. Now I'm going to use my calculator for this. I'm going to write this 2% as 102%. Okay, 102, I've actually got a percent button. You can write this as 1.02, but I like to work in percentages because we're working in percentages. Times 250. Okay, so in year 1, it's going to be 25500. I'm going to get that answer, I'm going to times that by 102% again. And I know there is shortcuts, I'm not choosing them to do it. My second year is 26010. And my third year, I'm just doing exactly the same thing. Okay, so I'm going to get my answer, I'm going to times it by 102%. S to D. So it's going to be 26530.2. So I've got 20p. Now this one here, my secure bank. This actually is 0. Okay, so I'm still starting with 25123. So it's 4.3% for the first year. So I'm going to 25123. I'm going to times it by 104.3%. And just to be clear, I'm doing it by 104.3 to include the 100%, which is the original amount, and the 4.3. So in year 1, I got 26075. Now it's 0.9% for each year. So I'm going to times this by 100.9% to get from my second year, which is 26309.675. I'm not going to wind around it because I just don't want to. Times 100.9%. My third year is 26546.46208. Which one's better? So it's going to be Secure Bank's better. Secure Bank is better. Okay, a number n is rounded to 2 decimal places. The resultant is 4.76. Using inequalities, write down the error interval for n. Now, I like to write my upper bound and my lower bound because that helps me out in questions like this. Now, my upper bound is the highest number this can go to, which then would round to that, which is 4.765. In 90% of the cases, it's just this number with a 5 on the end. My lower bound, you've got to think, what's the lowest number that if I round will get to this? Now, 4.755. Because this to 2 decimal places will round to that. If there's any less, it will round to 4.75. So we need to write it with inequalities. So I put x on the end. I put my 2 arrows. My lower value's got to go there, because that's the way it's pointing. And my upper value's got to go here, 4.765. Now the question is really that this number, 4.765, that should really round to 4.77. So it can't be this number, it's got to be the one below it. So I don't put an equal sign here. But that one there, 4.755, it can be. So I put my equal sign there. You can have it flipped around the other way as well with all the signs facing the other way. Okay, question 24. Solve x squared plus 5x minus 24. First we've got to factorise. We can't take a common term out, so put x and x. And remember, you can complete the square and you can use a formula if you want to do that, but I'm not gonna. I'm just going to factorise it and solve. I need 2 sets of numbers that multiply to give you minus 24, but add to give you 5. I like to list all my 2 numbers that multiply to give you minus 24. 2 times 12, minus 3 times 8, minus 4 times 6, minus 5 doesn't work, so I'll cross it out. And then remember, I've got all the ones with the signs flipped. So 1 times negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. And you might think this is a long way, this will always work. Now you need to know which one of these add up to give you 5. This adds up to give you 23. These add up to give you 10. These add up to give you 5. Oh look, that is 5, it's got to be that one there. So minus 3 and plus 8 equals 0. To solve it, remember, I would have to make that bracket equal to 0 or that one, because anything times 0 is 0. So if this equals to 0, x must equal positive 3. And if that equals to 0, x must equal negative 8. And there's your 2 answers. X is either plus 3 or negative 8. Here are the first 6 terms of arithmetic sequence. Find an expression in terms of n for the nth term. So what we do now, we look for the common difference. Difference between 3 and 8 is calculator paper. It's the end of the paper, so I'm a bit tired, so I'm going to use my calculator. It's 5 between 8 and 13. 5, 13 and 18. Is 5, I think we've done enough to know the nth term's 5. So it's going to start off with 5n. Now we're going to think about how do I get from 5 to 3? Well, you minus 2. So the nth term is 5n minus 2. If you wanted to check, let's do our 4th term, which is this one here. 5 times 4 is 20. 20 minus 2 is 18. Well done, we're correct. Part B. The nth term of a different sequence is 3n squared. Nathan says the fourth term of the sequence is 144. Is Nathan right? So fourth term of the sequence, n's going to be 4. So it's going to be 3 times 4 bracket squared. Okay. Now you can just type into your calculator 3 times 4 squared. I put 4 in brackets because sometimes you have to deal with negative numbers and it confuses your calculator, which is 48. So you can say no, he's wrong. Now you might think, oh, that's a bit of a stupid question, but I would imagine what they expect you to do, and they expect you to do this incorrectly, is to do 3 times 4, which equals 12, and then you square it, which equals 144. The second way is not correct. This is not following your rules of BIDMAS, which are BIDMAS or BODMAS, whatever you want to call it.